so I can get it down to something that I can eventually factor. And I'm going to have to rewrite this as this. So I've got, if I rewrite it, and we did one of these in class, and we're going to rewrite this using the u substitution. That'll give us a polynomial. We'll factor it, and whatever we get, we've got to check and make sure that it doesn't give us an incorrect answer. So we're going to get a couple of answers off of this one. We're going to solve this with a substitution. Let me remember where that is so I can show an example of how that works, just to go over it again with you. We did one that was very, very similar. This looks like 491, example 4. Remember, this is what they did here. Move it up so we can see it. It looks like this. Ours is similar. What they did first was they rewrote it as an e to the x squared, because you can do that. Then they applied our u substitution. They got a polynomial, and then they factored it. So we're gonna do that. We're gonna rewrite it. We're gonna use our u substitution, and we're gonna factor out the resulting polynomial. So I can rewrite this as 3 to the x power quantity squared. It's the same thing. Minus 3 to the 3x power equals 40. And I'm going to let u equal e to the x. Right, this is a substitution. And this is something, if you take a calculus course, that you're going to be doing a lot of. Now we can rewrite e to the x as u. So that is then u squared minus 3u equals 40. And now we should be able to solve this by moving that 40 over. And we've got u squared minus 3u minus 40 equals 0. And we should be able to factor this pretty easily, because we need a minus 40. And what two numbers are going to multiply together to give you 40? Subtract from each other to give you a 3. Huh? Yep, 8 and 5. And which one's positive and which one's negative? Okay, yep. Sign in the middle is negative, so that means larger number is negative, so that's a negative 8. Positive 5. That then factors into u minus 8, u plus 5, right? Equals 0. So now we've got u minus 8 equals 0. So u equals 8. What was u again? U was e to the x. And how do we get rid of the e? We use remember, I know it's been a while. Yep, ln. So we take the ln of both sides. And now we've got x equals natural log of 8. And you can leave it as a natural log of 8, or you can break it down. Oh, let's see. What does it say to do? It says give the exact form, so leave it as a natural log of 8 there. What about the other one? The other one is u plus 5 equals 0. So u equals negative 5. So e to the x equals negative 5. But why is this not going to work for us? Right, because when I try to take the natural log to get rid of that, this right here doesn't work. Right? Cannot take the log or natural log of a negative number. So the only solution that we then have is going to be x equals what? Natural log of 8. Right? Not just 8, natural log of 8. Yeah, and that's fine too. If I can check them when I grade it, if you give me the decimal, that's fine. Or you can leave it as a natural log like that.
Can you give us
the decimal answer? Okay, so let's see what that would be. You want the ln of 8, and so it should come out to be 2.079. Close enough. Yep, close enough. Okay. It says use the exact form, but if you turn in the decimal, that's fine too. Okay, I don't care either way. Where'd you get the 1.9 from? Okay, there might have been a mistake somewhere else, but you should have got u equals 8, which means that e to the x equals 8, and then take your natural logs. So it should have been that. I'll write down the answer here. It should have been 2.0794 if you round. But I'll take either one. It says give the exact answer. I'm not as picky as some instructors are. If you gave me the decimal, that's fine, but this is the exact answer. And sometimes you might want the exact answer because if you use it for further calculations, if you round, then once you do more calculations with it, your error compounds itself. So in some cases, you might want to keep the exact answer so you don't have any round off. Question 7 is next. And question 7, we're going to have to use some different properties to work this one out. We're going to see what we've got here. We're going to figure out how we can approach this one. And this one says, round to the nearest thousandth. So 10th, 100th, 1,000th, 3 places. We're going to take it out to 4 so we can round at the end to 3. Well, what would I do first? Well, what do we know? We know that a natural log, right, will get rid of an e. So we can go ahead and divide by 4. And that's going to get that e by itself. So let's divide this by 4. And then I'm going to reduce. So that gives me e to the 3x plus 2 power equals 1/2, right? Is everyone okay with that? What do we need to now do? Natural log. ln and ln. And we can use a decimal here. So let's go ahead and work this out. The left-hand side is going to come out to be 3x plus 2. And the right-hand side, we're going to take the natural log of 0.5. So the natural log of 0.5 is, fractions are negatives. Anything less than 1 is a negative number. But you cannot take natural log of a negative. So anything between 0 and 1, when you look at a fraction, is going to be a negative. But you cannot take the natural log of a negative. So that's going to come out to be minus 0.6931 if we round. Close enough. And then what are we going to do? Solve it. Move the 2 over. And that is then 3x equals a minus 2.6931. And last step is going to be divide by a 3. And so now we've got x equaling what now? Okay, we use our calculator here. So we're just going to take this minus 2.6931. We're going to divide that by 3. And we should have ended up with an answer of minus 0.89 if we round 8. Close enough. Is everyone all right with how I solved that? And if you're off by a bit on the rounding, that's okay. Yep, let me move the calculator. Try to keep it up so we can see it all up on the screen. So let's review what we did. When I solve this equation, I want to get it to the point where I can get the e, the exponential, by itself. So I move that 4 over. And then I reduce that 2 over 4 down to a half. And then I was able to take the natural log of both sides to clear out the e. And then that power came down. So then I could just simply solve it out. And I took it out to one more decimal place than what we needed.
So it's minus 0.89.
Yep, minus 0.89. Yep, 8 it looks like. And if you're off a little bit on the rounding, that's okay. As long as it's minus 0.89 something. That's close enough. Okay, so are we okay with how we did that? The last one that we asked about was question number 9. So question number 9 is an application. So let's see what we've got. We got to figure out how we're going to solve this equation out. And I believe that this was the easier one. Because I did 10 for you last time, if I remember right. So 9 should have been the easier one. And suppose the government wants to impose a tax on fossil fuels to reduce carbon emissions. The cost benefit is modeled by this equation. Natural log of 1 minus P equals minus 0.0039 minus 0.0048x, where x represents the dollars of tax per ton of carbon, and P represents the percent reduction in emissions. P is going to be in a decimal form. Determine P when x is 52. So we're going to plug in to this equation 52, and then we're going to see how to solve it. So it looks more complicated than what it really is. We're going to plug in our 52, we're going to break it down, and then we're going to see how to solve that exponential. And so this is question 9. And we've got the natural log of 1 minus P equals minus 0.0039 minus 0.0048. And I'm going to plug in x equals that 52. So that's the first thing I'm going to do, is I'm going to plug in that 52, condense down the right-hand side, and then take e to get rid of it. So putting these together, we've got a minus 0.0039 minus 0.0048 times that 52. We're going to do it all at once, put it together, and that should come out to give you that. So that should give you a minus 2.535. And that equals the natural log of 1 minus P. Okay, so how do we get rid of an ln? Does anyone remember? Okay, how do we get rid of an e? We use an ln, right? So if we have an ln, how do we get rid of it? We use an e. So take e of both sides. When you take an e, that clears that and that out. Right? E and ln are inverses. Just like log and a tan are inverse. So I use the e to get rid of the natural log. And the left-hand side is 1 minus p. And the right-hand side, we're going to work this one out. And it says round to 3 decimal places, so we'll go out to 4. So we get 3 at the end. And we want second ln, that puts the e on the screen there. Right? Remember how that works? Second ln, right? And that puts that e up there. And then you use your negative key. Now, which key do you use? You don't use this key, right? You use this one at the very bottom. That's the one you're going to be using, minus. And what number do we type in? Type in our decimal here, 0.2535. And then we hit enter. And that gives us then that. So that is 0.776 if we round 1, close enough. Move the 1 over. And minus p now equals, let's take 1 from that. And yep, it's going to be negative, so that's going to be a minus 0.22. Now we can round it. Well, we want our answer in what? We want our answer in 3 places. So that's going to be our answer, because we'll just get rid of the negative. So that's going to be a minus 0.224. We'll divide by our negative 1. And that gives us an answer of p equaling now 0.224. Close enough. And what is that? Okay, that is the percent of reductions in emissions. Close enough. Yep, good enough. As long as the first 2 places are correct, that's okay. or even just maybe the first one. But sometimes you get round off, because if you write answers down and you round off and use that in a calculation, it'll start accruing a little bit of round off error. But as long as it's close enough. Yep, these aren't exact answers anyways. This is more statistics. And when we look at modeling, it's just a best guess. So it's fairly close. But this just says, if I impose a $52 tax on carbon, then I should end up reducing my emissions by about 22.5% or 22%, somewhere in that range. Okay? And that's all that's saying. So, the government and different agencies can use that information to try to figure out, well, if I put a tax on, how much am I gonna decrease my emissions by? But at the same time, you don't want to put tax on, because then that costs money for people. So it's kind of a give and take. But there's lots of different models out there to figure out what's the best case for solving the crisis that we're in, depending upon the crisis. But that just says putting tax on something, on carbon emissions, reduces the carbon emissions. So, any other questions out of 4 or 5? Anything else out of 4 or 5? All right. Well, I'll go ahead now and pass out your next homework packet. And this will be your last homework packet. So this will be the last one that we're going to be working on. And when are you going to take it on? Yeah, you want to take it on Thursday? Yeah, we said we'll take it. And don't worry about that. Just kind of follow along, because it won't be due until after you're gone. So don't worry about this one. But do make sure, though, that you bring back on Thursday your take-home final and your practice. I'll exempt that one. I passed that up earlier. That is the schedule for your final exam. Yeah, you're going to take it on Thursday. I just have you take it in my office during class time. Okay, I'll have you take it during this Thursday, in my office. Okay, so just come to the classroom and then I'll put you over in my office. Okay. But yeah, don't worry about trying to rush through that assignment, because I'll exempt that one since you're leaving it. So let's now go ahead and start looking at Chapter 5. And Chapter 5 is Systems of Equations. And some of you might already be familiar with systems of equations and how to solve them. We're going to look at some different procedures that we can use to solve systems of equations. Now, when we talk about systems of equations, there's 3 basic techniques that we can use. Well, 4, we'll learn another one next class on Thursday. But the 3 we're going to be talking about today, hopefully we can get to the last one, is we're going to learn substitution, elimination, and Gauss-Jordan. Now, what a system is we have the same number of equations as variables. And we're going to start off by learning substitution. So this is an example of a system. And when we solve these out, we have to get our ordered pair. So our answer is going to be in an ordered pair. And I'll pick these from our textbook. This way they come out to give us nice whole numbered answers. And we'll start with an easier one here. And this is going to be using substitution. So we'll look at page 536. We're going to look at question number 8. It is 3x plus 4y equals 4. And x minus y equals 13. Now again, there are many different ways to solve these. It just depends upon how the equation is structured as to what method is the easiest. Substitution is not used that often. It's the least used method. It only works really nicely when something's already solved for a variable. In this case, though, it's not, but we're still going to try to solve it with substitution. Now, when we solve it with substitution, what we're going to be doing, okay, is we're going to be solving it for one variable, and we're going to be plugging that variable into the other equation. Because we've got two equations, 1 and 2, and we've got two variables. Now, when we use substitution, we really want to try to avoid dividing. We want to keep it as easy as possible to deal with. I have to solve it for one of the variables to use in the other equation. If I use the first equation, it's got these 3's and these 4, the 4 in front of the x and the y. And that would make a fraction, and we want to avoid that. So what I'm going to do is I'm going to take the second equation, and I'm going to solve it for x. That's going to be our easiest way to work it through, and then I'm going to plug it in the first equation. So solve that second equation for x. It's going to be the easiest one to do. So take that second equation and solve it for x. So we've got x minus y equals 13. So we're going to add our y. And now we've got x equaling y plus 13. Yep, you can. Yep, that'll make it a little bit quieter. Thank you. We took the second equation, right? And we solved that for the variable x. Now what we have to do is we use that second equation. You have to use them both. So I checked it off because we used it. We have to use the first one. So we now take this and we substitute it into the first equation. So take what you found from the second one, substitute it into the first equation. And when I substitute that into that first equation, that is going to then give you 3. Now, x was what? X was y plus 13. Okay, so plug that in. Plus 4y equals 4. So we take whatever we find and we plug it in the other equation. Now look at what we have. Well, now we've got something that we can solve directly for one of the variables. There's only one variable left, and we can find that variable as a number. Right? So we can actually solve it. That's what we do. We eliminate one of the variables, the substitution, to get the other one. So let's finish this up. Distribute that 3 through. So that is then 3y plus 39 plus 4y equals 4. So those can go together, and that makes it 7y. I'm going to move that 39 over. And so now we've got 7y equals 4 minus 39. That's a minus 35. Divide by our 7. And that gives us y equaling what now? Okay, minus 5. This is substitution. Okay. There are 3 ways, again. Substitution, so it's the first several in your homework. Elimination is what we'll look at next. And then Gauss-Jordan. Now, quite frankly, it doesn't matter how you solve it, which method you use, but I'm going to show you all 3. If you want to do them all with elimination, you can. If you want to use substitution all of them, you can. Substitution, though, is probably the one that you use least often. Now, we are not done yet. Okay, because what do we have? We have x's and y's. We found the value of y. How do we find the value of x? To find the other value, we plug it in. It doesn't matter where we plug it into. Once you find one of them, you just plug it in. Where's going to be an easy place to plug it into? Well, I would say plug it right there. You plug it wherever you want, as long as you can get it down to one variable. So we can just plug that in there. And if I plug that in there, then I get x equals minus 5 plus 13. And so x equals now what? 8. And how do we write our answer as an ordered pair? Well, it's xy. So that's 8 comma negative 5, and that's your answer. Okay, so there is your answer right there. Let's try another one. How about we look at, that was question 8. How about we look at question 10? Question 10 is actually easy. Yep, these are substitution on these. Yep, both of these are going to be solved with substitution. And what we've got on 10 is we've got 6x minus y equals 5. And we've got y equals now 11x. This one's actually easier than the last one. Why is this one easier? Well, I've got my two equations, but look at my second equation. Well, it's already been solved for y, hasn't it? So all I have to do is what? Plug it in. And when I plug it in, that gives you 6x minus 11x, because that's your y, right? That equals 5. So putting those together, 6 minus 11 makes it a minus 5x equals 5. Divide by a minus 5, and we've got one of them, which is x now equaling what? Negative 1. What do we now do? We need to take that negative 1. We need to plug it in somewhere. Wait, yeah. Everything looks right there. Make sure. Oh, wait, did I miss a sign here? Let me make sure I didn't miss a sign. It says it should. No, I was right. Yep. Sorry about that. Just looking at the wrong answer. It should be negative 1, which is what we got. Okay, we need to get the other one. What do we do? This is part of it. Plug it in somewhere. Does it matter where we plug it into? Nope. Easiest possible place is right there. Because I can plug it in right there. And that gives you y equals now 11 times a negative 1. So y equals now negative 11. So as an ordered pair, your answer would be negative 1, comma, negative 11. And it's an ordered pair because what it is two lines like this crossing. And they're going to cross at a point, right? And that point is where they cross. That was using what's called substitution. And substitution really only works when it's already been solved for a variable, like this one, y equals. Okay, it was solved for y, so substitution was the easiest way to solve it. Elimination is what we use most of the time. For most cases, elimination, or Gauss-Jordan, which is basically the same thing, is what we're going to be using more than anything else. So we're now going to solve with elimination. So we're going to try to solve this with elimination, and I'm going to pick two of these from our textbook to look at. We'll do one with fractions and one without. So page 536. We'll look at question 12, which is 12x minus 5y equals 9, and 3x minus 8y equals a negative 18. Make sure everything is right here. Right. So we're going to try to solve this with what's called elimination. Now, I wouldn't want to use substitution because we are going to get a whole bunch of fractions. And we do not want to use fractions if at all possible. So we're going to have to try to solve this with elimination. And when I look at elimination, I try to get rid of one of the variables. And I look at them in terms of the numbers in front. The x has a 12 and a 3. The y has a 5 and an 8. Well, 5 and an 8, they don't have anything in common. Okay? But what about 12 and 3? They do, right? Because you can take 3 times what to make it 12? 4. So let's go ahead and take our second equation here, and we're going to try to eliminate for the x, so we're going to multiply it by a 4. But we're not just going to use a positive 4, we're going to use a negative 4. Why am I going to do that? Because this one has 12x here, right? And if I use a negative 4, well, that would make this one then what when I distribute? Negative 12x, and they'll cancel. So we're going to eliminate for the variable x. I could have eliminated for y, but it would be more work, right? Because 5 and 8 have nothing in common. I'd have to use a 40 for the least common denominator, and that would make it a lot more complicated. You want to reduce down the number of steps as much as possible. And we're going to eliminate for the x here. So we take the first equation and we keep it the same. And the second equation, we're going to distribute this negative 4 through. Each piece gets the negative 4. So that leaves me then with a minus 12x. Now watch your signs. Negative and negative makes it a positive. And 4 times 8, that's a 32y. And negative 4 times negative 18 makes it positive. And you really don't want to make a mistake, so use a calculator. Where students make a mistake is mental math, and if you're not really, really careful, you'll make a mistake. So use a calculator and take your time. That gives you that 72. So is everyone all right with that so far? Okay, now what's going to happen when I add down? Well, when I add down, the x's, they do what? They cancel. Okay, so those go away. So what are we left with? When we add down, minus 5 plus 32. So that is 27y. We add down, and 72 plus 9, that makes it an 81. And now we can solve it for y by doing what? Yep, divide that by your 27, and that leaves you with y equaling now 3. Okay. Now, how can we get the other part? Well, we could eliminate for the y, but that would be a lot of work. The absolute easiest way to do this is just like we did before. We take it and we plug it back in. So we've got y equals 3. Okay, so we're going to plug this back in somewhere. So let's plug it in our first equation right here. Doesn't matter where we plug it into. We're just going to plug it into one of them. So I'm going to plug that 3 into that first equation. So that is then 12x minus 5 times 3 equals 9. So that is then 12x minus 15 equals 9. We'll add our 15 to each side. And that leaves us then with 12x equals 24. Okay, we'll divide by our 12 here. And x now equals what? 2. And so what's our answer as an ordered pair? 2, 3. so we can see. I'm trying to keep it all on the same screen here. Okay, is everyone okay with how I did that? Right? So you just use elimination, get one of the variables, plug it in, get the other one. If they have fractions, you're going to have to clear the fractions to begin with. There's only one of these in your homework, but there is one of them. I'm going to look at question 29. And again, this is page, this one's 537. We're going to use elimination again. And we're going to look at question 29. What we're going to have to do on this one is we're going to have to clear the fractions first. And this, I think, is the most difficult question from the homework, just because there's a lot of algebra. So move it up so we can see. I'm trying to keep as much of the other question on the screen as I can. X plus 3 over 2. And then we've got a minus x minus y over 3. So what we're going to have to do, before we do anything else, is we're going to have to clear out all of these fractions. Oh, sorry about that. It equals 3 here. Now, we're going to have to work these out independently of each other. We're going to have to split all these fractions up into individual parts, and then we're going to have to clear the fractions. So we've got two equations, and I'm going to have to do them separately. So let's start with one. So start with your first equation. Now, what I'm going to do to make it easier is I'm going to split this up into individual parts. So I'm going to split this up into 2x over 3 minus 1 over 3 plus y over 4 plus 2 over 4, and that equals 4. So all I did was I just split it up. Right? I just split it up, split it up, split it up, split it up. And now, what's my two denominators? 4 and 3. So what am I going to use to clear my fractions? 12. Okay, so go ahead now and distribute the 12 through. So what do we do? Divide, multiply. Divide by the number below, multiply by the number on the top. So 12 divided by 3 is a 4. 4 times 2 makes it an 8x. 12 divided by 3 is 4 times a negative 1 makes it negative 4. 12 divided by 4 is 3. 3 times y, that makes it a 3y. 12 divided by 4 is a 3. 3 times 2 makes it a 6. And do not forget the other side. 12 times 4. Well, 12 times 4 is a what? 48. Now we've got to clean this all up and get it in standard form. Yep, so 8x and 3y can stay here. Right, correctly here, 8x and 3y. I'm going to add the 4 and subtract off the 6. And that leaves me then with 48. Minus 2 it looks like, and 48 minus 2 makes it a 46, doesn't it? Is everyone okay with how I did that? Just, if you need to write out extra steps, you can. Take your time. Where students make a mistake on these is in the algebra. It is so easy to just add a number wrong or accidentally multiply incorrectly. This is half of it. Now, we need to take the other equation and clean it up. So now we're going to start with our second equation. Now we're going to start with number 2. We're going to do the same process. Now, we do need to be very, very careful when we split it up, because notice this negative. This negative here is actually going to be distributed through. So that negative is down in the middle, so it's got to be distributed through. And we're going to write it as individual fractions again. I think that's the easiest way to avoid mistakes. So as an individual fraction again, that's going to be x over 2 plus 3 over 2. Now that minus gets distributed through, so that's minus x over 3. The double negative makes it a positive y over 3, and that equals 3. So we took everything and we split it up and we distributed that negative through. Very, very important that you distribute the negative through. Now, we need to clear our fractions, so what do we have to multiply all of this by? 6. And what's going to happen when we do that? Yep. Divide by 2, multiply. So 6 divided by 2 is 3. 3 times x, that makes it a 3x. 6 divided by 2 is a 3. Times 3 makes it a 9. 6 divided by 3, that's a 2. Times x, it's a negative, so that makes it a minus 2x. 6 divided by 3 is 2. 2 times y makes it a 2y. And do not forget the right-hand side. So 6 times 3 makes it 18. Now we can combine. So 3x and a minus 2x, that leaves you with an x, plus 2y. I'm going to move the 9 over. And now we've got our second equation, which is x plus 2y equals now 9. Is everyone okay with that so far? We took our time and worked it all the way out. Now what do? Now we actually begin the process of working with this. So now we've got our 2 equations, which are here and here. Now we're going to use elimination. And that's why I only gave you one of these. These take more time than anything else. So now we're going to work with what we've got. We've got an 8x plus 3y equals 46. And we've got 2x, sorry, not 2x, just an x, plus 2y equals 9. So we condensed it down, we got rid of all of our fractions, and now we're at this point. We're at this point and we want to use elimination. I wouldn't want to eliminate for y because I've got a 2 and a 3. I can eliminate for the x by just taking the second equation and multiplying it by 1. Yep, minus 8. That's going to make a negative 8 there, which will cancel out with a positive 8. So go ahead and distribute the negative 8 through. So we've got 8x plus 3y equals 46. Distributing the negative 8 through, we've got a minus 8x minus 16y. Negative 8 times 9, well, that's a minus 72. And now we can add these together. The 8's cancel. And we get 3 minus that 16y, so that makes it a minus 13y. And we've got 46 minus that 72, which that comes out to be a minus 26. We'll divide by our negative 13, and now we've got y equaling what? 2. Okay. What do we now do? We've got one of them. What do? We take it, plug it back in. Does it matter where it needs to go? Nope, we just plug it in somewhere. I'm just going to take this and plug it right in there. Easy enough. And that gives us now 8x plus 3 times 2, and that equals that 46. So that's 8x plus 6 equals that 46. We'll move our 6 over. So 8x equals 40. Divide by our 8, and x now equals 5, doesn't it? Okay. So what's our answer? As an ordered pair, the answer would be 5, 2. Now, you only have one of these in your homework. There's only one. It makes you work with the fractions. I only gave you one of them. The rest are pretty easy. So what we've done so far is we've only done this with 2 variables. Now this can be extended out to as many variables as we need. We're now going to extend this out to 3, and we're not going to go anything past 3 variables. But we're now going to look at how to solve 3 equations with 3 variables. And then we'll come back and we'll look at some that give you either no solution or an infinite number of solutions. So we're going to work through one of these. And let's look at question number. I'll try to pick one that makes us do all the different steps. How about question number 53? And this is on page 538. Question 53. These are not really that difficult. You just need to be very, very careful with signs. Because it is so easy to write something down wrong, or add wrong, or multiply wrong. See, I about wrote something down wrong there. This should be a minus z. Make sure I copy it down correctly here. It's so easy to make a mistake with these. And we've got a minus x, a minus y, a plus 4z, and it equals 3. Make sure I copied it down exactly the same here. It won't work. So x minus 3y minus 2z equals a negative 3. And we've got 3x plus 2y minus z equals 12. And we've got minus x minus y plus 4z equals 3. Okay, so we now need to get this down to 2 variables and then get it down to 1 variable, get the answer for that 1 variable, and plug it all the way back in. So we just work our way back up. Now, what we need to look at is we need to look at all of them in a whole, as a whole, and figure out what variable is probably going to be the easiest to eliminate. Now, we want to avoid excessive multiplications. When I look at this, and you can eliminate for any variable, I'm just going to try to pick the easiest one. I would want to try to avoid using the y, because the y has 3 and 2, and those have nothing in common. Now, we could eliminate for the x pretty easily, no problem there, or we could eliminate for the z, because 2 and 4 can go together. But I would really try to eliminate not the y, because that would be the hardest, because they have nothing in common. The absolute easiest would probably be the x, because those can already go together, and then that can go together with that. So you want to pick the ones with the smaller numbers. And when we do this, we have to make sure that we use all 3 equations. And we're going to work with them 2 at a time. Now, it doesn't matter which order we pick them, but we have to use all 3. So I'm going to say starting with this variable x, so we're going to eliminate for x. I would say 1 and 3. Now, why would I say 1 and 3? Because if we're looking here, well, these just go together and they already cancel, don't they? Right? See why that would be the easiest pick? Because those can just go straight away. So let's go ahead and use 1 and 3. And again, we're going to eliminate for that variable x. So let's go ahead and do this and eliminate for that variable x. Now, what's going to happen when I take 1 and 3, which you've done right here, and we'll put a check mark, 1 and 3, so we're going to use those. When I put them together, what's going to happen? Well, already the x's go away. So the x's are gone, right? And then minus 3 minus 1 makes it a minus 4y. Minus 2 plus 4 makes it a 2z. And the 3's go together and make it 0. Is everyone okay with that so far? Right? So.
What's the 8 sign?
Okay. The x's, where'd the x's go?
No, I mean 1. What's the 8 sign?
Okay, so this is what we're starting with here. Now, we have to use all 3 equations. I'm going to pick them 2 at a time. So I'm going to take the first equation and the third equation. And that goes here. Now, when I just take these 2 equations and I put them here, what's going to happen when I add them together? Okay, the x's, they do what here? They cancel. And then we have a minus 3 and a minus 1 that makes it a minus 4. And then we have a minus 2 and a positive 4 that makes it a 2z, because those go together. And a negative 3 and a positive 3, well, that makes that 0. Does that make sense? Okay. Now, which equations have we used? 1 and 3. What equation do we have to use? 2. Now, we have choices. We can either use 1 and 2 or 2 and 3. It doesn't really matter. They're about the same. So, let's do 1 and 2. Doesn't matter which ones we use, but we have to use equation 2 somewhere. So, I'm just going to use 1 and 2. And again, we're going to eliminate for the x. We cannot change what variable we eliminate for. We have to get it down to be 2 variables. So we're going to eliminate for the x here. And we're going to use 1 and 2. So x minus 3y minus 2z equals minus 3. And our second equation is 3x plus 2y minus z equals 12. Well, we want to eliminate for the variable x. So that first equation, what am I going to have to multiply it by? Minus 3, isn't it? Right? Because that will make that then a minus 3x and a positive 3x, and that's going to go away. So distribute your minus 3 through. And always be very, very careful with the signs. It is so easy to make a sign error. So distributing that negative 3x through, that gives me a minus 3x. Negative and negative makes it a positive 9y. Negative and negative makes it a positive 6z. Negative and negative makes it a positive 9, isn't it? The second one we just copy. And now when we add down, what's going to happen? Those go away. The x's go away, which is what we want. So the x's are gone, and that gives you 11y plus 5z equals, okay, 9 and 12, that makes it a 21. Now, look at what we have done. Let's take a moment to see what we started with. We started with 3 equations, right? 3 equations, 3 variables. Now, what do we got it down to? 2 equations, 2 variables. Same 2 variables, right? You can't have different ones. You have to have the same 2 variables. So at the very beginning, I saw that I have the 3 equations, and so I picked a variable to eliminate. Now, I cannot change it once I've started. So I said, okay, x looks like the easiest one to eliminate. So I took 1 and 3, eliminated for x by adding. 1 and 2, eliminated for x by multiplying and then adding. Now look at what I've got. Now they should have the same 2 variables. If they got different variables, you made a mistake. So now we can eliminate again, because now we've got 4y plus 2z equals 0, and we've got 11y plus 5z equals 21. Okay, make sure you're very, very careful when you write things down and do not copy it down. That's where students make the mistake, is they copy it down wrong. Now we need to eliminate. Which one looks easier to eliminate? The y or the z, do you think? Do you want to work with 4 and 11 or 5 and 2? Which one looks easier? I would say 5 and 2, right? Because 5 times 2 is what? 10. If I use the y, I'd have 4 times 11, which would be 44. So I'd rather work with 10 than 44. So I'm going to take these 2 equations, and I am now going to eliminate. Okay, I'm going to eliminate the z. Okay, so I need them to be the same. And what I look at on these is I eliminate the z, and I look at my z, and it's kind of like the least common denominator of 2 and 5. Well, the least common denominator of 2 and 5 would be what? 10. Okay, so what do I need to multiply the first equation by so that I get a 10 there? 5. And what do I need to multiply the second equation by? 2. Now I have to be careful because I can't just use 5 and 2 because they would be the same and they would add together. I need to make sure that one of those z's is a positive 10 and one of those z's is a negative 10. Now, it doesn't matter which one, so I'm going to make the top one negative. But it's irrelevant as to which one you choose. Okay, distribute that negative 5 through and be very, very careful with the signs. This is where students make mistakes. Negative and negative makes it a positive 20y. Negative and positive makes it a negative 10z. 5 times 0 is still 0. Now, same thing on the next equation. Distribute the 2 through. When I distribute the 2 through, I get 22y plus 5 times 2 is a 10z. 2 times 21, well, that's a 42. Now what can we do? Now we're lucky because we can add down, and that gives you 42y equals now 42. So we divide by our 42. And now we've got y equaling what? 1. All right, now we need to get the other 2 variables. So I'll take a moment to slow down so we can get caught up here. Okay, now we've got one of the variables. So we're almost done. We got to get the other 2. How do we get the other 2? Well, we plug it back in. But we have to make sure where we plug it back into has only one other variable so I can directly solve it. So if I plug it back in the original, it's got 3. I only know one of them. So you need to make sure when you plug it back in, you get one missing variable. So I'm going to take this, y equals 1 here, and I can plug it there, can't I? Right? Because that would give me z. So take that. And you could have either plugged it there or you could have plugged it in here. Either one. Doesn't matter. It's the same. It's going to give you the same answer either way. So either here or here. I'll just plug it in there. And if I plug that y equals 1 in, then I get 11 times 1 plus 5z equals 21. So that's 11 plus 5z equals 21. Move the 11 over. So 5z equals 20. Divide by your 5. And now we've got z equaling what? Let's see, did I make a mistake somewhere? No, I think I was right. Okay, because it's easy to look at things wrong. Don't worry about this part here, right? Because that's just our least common denominator. So we're going to plug our y equals 1 into here. This is our equation, right? You could have either plugged here or here, either one. So that's our least common denominator, and that's why I use different colors so we can see what's kind of going on here. I take this 1 and I'm going to plug it in here. And let's make sure we didn't make a mistake with our numbers when we subtract it. Yep, you're right. 21 minus 11 should be a 10. Yep, sorry about that. I was trying to figure out where the mistake was. And then those divide out, that gives you z. 10 divided by 5, that makes it a what? 2. Now what do? Now we've got two variables. How do we get the third? Well, we're on the right track. We now have to take it and plug it these two, right? Plug them all back into one of the original. Because what variable are we missing? We are missing x. Now, where do we have an x at? Way back up here. In any of these three. Does it matter which one? No. We'll just use the first one, but you can use any of them. So I'm just going to use the first one here. What do we know? Okay, we know that y is 1, z is 2. So I'm going to plug those in. And let's just plug it into the first one. Doesn't matter which equation. So I've got x minus 3y minus 2z equals minus 3. We're going to plug our values in. So that's x minus 3 times 1 minus 2 times 2 equals that minus 3. So that's x minus 3 minus 4 equals minus 3. So x minus 7 equals minus 3. Add your 7, and now we've got it, because now we know x equals now what? 4. We write our answer as an ordered triplet. X, y, and z. So as an ordered triplet, we've got 4, 1, and 2. And that's it. That's your answer. They take a bit to go through. It's not difficult. It's just very time consuming. And it can be very frustrating if you make a sign error. So be very, very careful. Now, if you start getting a whole bunch of fractions, you made a mistake. If you start getting really odd-looking fractions, somewhere you made a mistake, start over. And if you make a mistake on these, normally it's easier to just start over than to try to find it. If you try to find it, you'll probably get more frustrated. So on these, if you feel like you made a mistake and you start getting really odd, weird fractions, start over. Just start fresh from it. You might be able to find your mistake, but chances are you'll probably just get more frustrated than if you just started over. Now we have a little bit of time left. And there are 2 more special types of equations to look at. We'll cover question 10 on your homework next time. We just don't have time for Gauss-Jordan. The other class didn't either. So we'll do question 10 next time. But let's talk about 2 more types of equations. And when we solved equations back in chapter 1, remember there were three types. Conditional, right, where you got a solution. These have been conditional. You also had the identity, and you also had the contradiction, which was no solution. So we've done the conditional ones. Now let's look at ones where you get no solution, and then we'll do one where you get an infinite number of solutions. So these are going to give us now either no solution or an infinite number of solutions. Question 32 on page 537. We have 3x plus 2y equals 5. And we've got 6x plus 4y equals 8. Now we need to eliminate a variable. And it really doesn't matter which variable we choose to eliminate. We've got, on the x, we've got 6 and 3, which is easy. Y's, we've got 4 and 2. Doesn't really matter. How about we just go ahead and eliminate for x? So when I go to eliminate for the x here, I'm going to take my first equation, and I'm going to multiply it by minus what? 2. Why am I using a minus 2? Well, when I use that minus 2, that makes that a minus 6x, right? And below it is a positive 6x, so those are going to cancel out. And that's what we want. We want to see that. So now when I distribute through, I get a minus 6x. I get a minus 4y. I get a minus 10. And down below, I get a 6x plus 4y equals 8. Now, how is this one different from the others? Well, when I add down, what's going to happen on the left-hand side? Everything goes away, and that leaves you with 0. What about the right-hand side? Negative 2. Does 0 equal negative 2? No, this is false, right? And remember, if you had a false equation, it had no solution. Now, we do use a slightly different terminology. We don't call it a contradiction. We call it an inconsistent system. And an inconsistent system, it has no solution. Now, what do I mean by an inconsistent system? If we think about it as lines, normally what happens? Lines cross at an x like this, right? Now, how can you get the lines never cross? They're parallel, right? Parallel lines never cross. That's what these are. These have the same slope. These are parallel lines. And parallel lines never cross, so that's why it has no solution. And it's called inconsistent. The opposite of that is where all of it falls on the same line. And this will be the last question that we're going to look at. So I'll go ahead now and pass out the sign-in sheet. Okay, so we're going to look at one more, and this one's going to have an infinite number of solutions. And it's going to be true. It's going to be like an identity. So that one had no solution. It was inconsistent. Now the next one's going to have an infinite number. Oh, sure. Yep. Sorry about that. I'll bring that up so we can see what we've got here. So the next one's going to have an infinite number of solutions. So this one was like a contradiction in that when I solved it, I got something that was false. Now, the identity was where they were the same, right? And the identity was true. So the same concept applies on the next one, but instead of it being false, it's going to be true.
So on the test,
Huh?
on the test, if we put false,
Yeah, I would just want false, no solution. Just as long as you have inconsistent, no solution. So pretty simple on that. And on your exam, by the way, on the final, you might have something that's similar to this. I'm not going to give you 3 variables, 3 equations. It takes too long. On your final, I'm not giving you really, really difficult questions. I'm giving you lots of different types. So I'm focusing on making sure you understand some of the basics. So what we're covering is more complicated than what you'll see on your final. But this type of equation could be on the final. Something very simple like this. Let's now look at one that has an infinite number of solutions. Question 37. We've got 7x plus 2y equals 6, and 14x plus 4y equals 12. Now these are actually the same line. I'm going to go ahead and eliminate for one of the variables, and let's eliminate for the x. So we're going to take our first equation, and what would we need to multiply it by? -2. And if I multiply it all by -2, then I get minus 14x minus 4y equals minus 12, and the one below it is the opposite, exactly the same, but just different signs. And what happens when I add them together now? Everything goes away, right? And if everything goes away, what am I left with? 0 equals 0. And that is true. How do we express our answer? Well, we have to express our answer a little bit differently. And we still need to write it as an ordered pair. And these are called dependent equations because they're exactly the same. Right? And it's just a line. It's basically 2 equations that are the same. They form one line. Our solution is going to be on the line. So what we do is we take one of the equations, doesn't matter which one. So take one equation and you want to solve it for y. So we're going to take one of these equations and we're going to solve that equation for y. So let's just start with the first one. 7x plus 2y equals 6. So we're going to solve this for y, just like you were getting it in slope-intercept form. No different. So we take it, solve it for y. So now we've got 2y equals a minus 7x plus 6. Divide by your 2. And that leaves you with y equaling now a minus 7 halves x. And 6 over 2 makes it a 3. How do we express our answer? Okay, and this is just a different way of writing the answer. The way we write our answer is we write it as curly bracket, x, and then what did we find y to be? Y was minus 7 halves x plus what? 3. Okay, so that's all we had to do was take it and solve it for y, and that becomes the y component of your ordered pair. Yeah, we need a curly bracket there. So your answer would look like this. And all this is saying is basically it's just saying that my line, both of these are the same and they form a line. And anything on that line is a solution. And so it's a more complicated way of writing it, but x is the variable and x solved in terms of y is that. We're going to do question 10 next time. So your homework is 5, 1, and 2. You can do them all but 10. We'll do question 10 next time. And I was hoping to get to that question 10, but we just don't have enough time. And I don't want to rush through it and not get it finished. So 5, 1, and 2, you can do them all but question 10. We'll do 10 next class period. I also have quite a bit of old homework to pass back as well. So if you haven't picked up your homework in a while, I have it all up here. Please make sure you sign the sign sheet now. Oh, sure. Okay. So you see how I got... Okay. So what I did was... Okay. What I did was I figured out that it had infinite number of solutions. So then I go back to the original. And I went to the original and I said, I need to solve one of these equations for y. It doesn't matter which one. So I need to get it in basically slope-intercept form. So I said, okay, let's take this first equation right here. And let's solve that for y. So I took that equation and I solved it for y. So I went through and I moved the 7x over, and then I divided by my 2 and I reduced it down, and I got to here. Okay, now, how I write my answer is this is my variable x, and then this is the y. Well, what is y in terms of x? Y in terms of x is this. So that goes over here. So when you get a true statement, you just take one of the equations and you solve it for y,